Welcome back to my YouTube channel. Again, my name is Rica Casabuena from ECE41 of the Electronics Engineering Program of the De La Salle University Das Marinas. And for today's episode, we will be having Internet of Things Laboratory Experiment number 1 entitled Packet Tracer Connecting Devices to Build IoT with the guidance of our instructor, Engineer Emmanuel Longares. So for the objectives of our experiment number 1, we aim to get familiarized with using Packet Tracer 7.1 in its IoT connections. So for our background and scenario, in this activity, we will build a connected solar-based power supply, okay? So the sun charges the solar panel, which sends electricity to the battery for power storage and distribution. A power meter connected between them reads and displays the amount of power being captured by the solar panel. Because all devices are connected, meaning they have IoT capabilities, they register themselves with a registration server, allowing a user to monitor the entire system from a web browser, which is through running our PC. So for our required resources, we will be needing a Packet Tracer 7.1, okay? And we just have to follow the instructions here for every part to perform the experiment. So for part 1, we will be adding and connecting the necessary devices. So we will start with our 4 LEDs here, okay? Custom 1 LED, okay? Custom LED 1, 2, 3, and 4. A PC, which is our laptop. A PC, which is this one, PC 0. A switch, okay? This one, switch 0, which can be get from here, okay? From the components here. You just have to search for it. And then we will be needing a server. So we have to add the following devices by locating and dragging them to Packet Tracer's workspace. So this is the Packet Tracer workspace, okay? So we have to take note that LEDs or light-emitting diodes are electronic components used to emit light. So LEDs are widely used in electronics as a form of user interaction. So for part A, a PT solar panel device. PT solar panel can be found under End Devices Power Grid. So we just have to, continuing, we have to add another electronic components on our file here. So first one is a PT solar panel device. This can be found under End Devices, which is under Power Grid. So here on our section here, okay, under End Devices, so let's click End Devices here, and then let's click here Power Grid, okay. Under Power Grid, we have to find the solar panel device, so solar panel. So we have to drag it here. And then next one, we'll be using a PT battery device to store the energy from the solar panel device. So it's under End Devices, End Devices, Power Grid, and we have to search for the battery, okay, battery device. So let's put it here. And then for the third device, we'll be needing a power meter that will read, of course, the meter, okay. So we have to search it at End Device, Power Grid, and then power meter. You have to find power meter, okay, here. So these are the 3 components that we'll be needing for this experiment, in addition to the current electronic components. So next one. So for the next step, we'll be following the instruction using IoT custom cables. Connect the solar panel and the battery to the power meter according to the table below. We have to follow the table. And the IoT custom cable can be found under the connections. So let's have the connections here, which is the Thunderlight image here. And then we'll be using an IoT custom cable. So IoT custom cable. We have to find for that. Okay, this one, this brown wire here, and then we'll be connecting the components in accordance to this table. So for the solar panel, we have to connect the solar panel to our battery. So solar panel is DO, and then to the battery, okay, DO, and then the battery should be connected to the power. Okay, let's choose this. The battery should be connected. Okay, the battery should be connected to the. Okay, so for proper connection, we just have to fix the arrangement of the components. So let's have the solar panel first, because it will be the first one that will be connecting with the power meter. So let's go to connection, then IoT custom cable, and then let's connect the solar panel's DO port to the power meter's DO port. And then after that, IoT custom cable again, then we have to connect the battery's DO port, okay, to the power meter's D1 port. So that will be the connection for this part. So we follow the table. Then again, using our IoT custom cable, okay, connect the LEDs to the battery according to the table below. The IoT custom cable can be found under the connections. Use the table below to find the correct ports. So for our LED 1, we have to connect it to our battery. Okay, LED 1 will be for 1. So let's have the custom cable here. So LED 1 will be, okay. Okay, so following the connections, we have to connect, okay, the DO of the LED 1 to the D1 of our battery, okay, D1. And then Next one will be the D2. Wait a moment. Let's connect it using IoT custom cable again. So D0 of LED2 will be connected to the D2. Okay. And then another one will be the LED3 to our D3. And then our LED4. Let's have the custom IoT custom cable again. LED4 will be for the D4. Okay. So all of our LEDs are lighting up already. So as our note, packet tracer may name IoT devices differently. While the name will not impact activity, feel free to rename your devices for easy identification. So we can rename our devices here. So for simplicity, packet tracer does not implement power cable properly. Wiring and powering device involve concepts such as ground, okay, grounding, polarity, specific connectors, cable width, and more. For simplicity, packet tracer hides all these variables behind the multi-use cable IoT custom cable. So it's very convenient for us because when we will be using IoT custom cable, wiring and powering devices concepts such as ground, polarity, and the cable width are all included in the IoT custom cable. So in real world designs, make sure to select the proper cable and connector. So we have to select the specific and appropriate connectors for our circuit. So for our instruction F, using an Ethernet straight button cable, connect the Ethernet port at the solar power, battery, and power meter to the switch according to the table below. This is to ensure they can communicate with the server. So Ethernet straight through cables can be found under connections. So let's go to connections, and then we'll have to find for the Ethernet cable. Okay, Ethernet straight through cable. We have to find it. So for the next step, we will be connecting our solar panel using our copper straight, copper straight through wire here. So let's connect our solar panel to our switch using the fast Ethernet 03 connection. Okay. The next one will be our power meter using the same wire here. So this will be for fast Ethernet 04. And the next one will be same wire. Next one will be our battery. So this will be for our fast Ethernet and then our fast Ethernet 05. So this will be our who connection. Okay, this will be our who connection. And after that, we'll be proceeding with our part 2 or with our configuring the devices. So now that the devices are properly cabled, okay, they must be configured. So since the system relies on an IP network, the devices must be configured with correct IP information. Since the server is configured to also act as a DHCP server, the IoT devices should be configured as DHCP clients in order to learn IP information automatically. So to do that, we're going to follow this steps from A to C. So we should click the solar panel here, okay, double click it, and then we'll navigate to the config tab, and then gigabit internet, gigabit Ethernet 0. And then we have to select DHCP under IP configuration, okay? So after that, gonna exit this one. For letter B, we have to click the power meter, and then we'll have to go to config tab, and then fast Ethernet 0. And then we have to select DHCP under IP configuration, and we have to exit it again. And then for our battery, we have to navigate to config tab again. And then we have to go to fast Ethernet 0, and then under IP configuration, we should check DHCP. Okay, so let's exit it. So with that, we'll be having this question: what IP addresses were learned by the solar panel, power meter, and battery? So if you're going to click on this, the IP addresses were automatically learned or recognized by the three components, namely the solar panel, power meter, and the battery. Okay. So after that, we're going to proceed to step D. So before the device can operate properly, they must register to the server. So same with what we are doing when we're setting up, let's say, computer shops, okay, and piso Wi-Fi like that. So we have to configure the devices with the server's IP address to allow them to find and communicate to the server. So IP address is used to allow components or devices to communicate to the main server. So we have, this one, we're here already. We have to click the solar panel, click the solar panel, and then we have to navigate to the config tab. We have to navigate to the settings. Okay, so the IP address is here, 1.00.03 for our solar panel. So for our next step, we're gonna click the solar panel here. And then, after clicking the solar panel, we have to go to the config tab and then to our settings. And then we have to select the remote server under the IoT server. So we have to click this one. So we have to enter the following server information. Server address should be the same with our IP address, the one that I've shown you earlier. Okay, so that's 1.0.0.1, which is the same IP address attributed to the solar panel. And then we have to type the username, which is the admin, and the password as well, which is the admin. So we have to click connect after that. So let's just wait for it. And we have to repeat the process for the power meter, the battery. For the power meter, let's go to the settings. Let's click remote server. Then, let's just go back to our solar panel, remote server. And we're just going to have to copy the server address here. So after clicking remote server, let's paste the server address here and let's type admin. So let's copy this one and then let's have the password here and then let's click connect for the power meter. Okay. And if the refresh button here has loaded up, let's proceed to the battery. So again, it's under settings, then remote server, then username should be admin, password should be admin, server address, let's copy it from our power meter here. Okay. Then let's go back to our battery here, then let's paste it here and then let's click connect. Okay. So after the configuration of our system, okay, we will go to our part 3. We will be using the system already after the configuration. So let's have, now that all devices are connected, notice how the solar panel charges the battery, okay? So now we shall proceed to our part 3, okay? So now that all devices are connected, so we should notice how the solar panel charges the battery, okay? So notice how the LEDs draw power from the battery for operation. So the LEDs are drawing power in the sense that they are lighting up, okay? As you can see here, only 3 LEDs are lighting up. Maybe because the power from the solar panel is not that enough to power all of the LEDs, including the 4th LED, okay? So notice how the LEDs go dark if the battery has no charge. So we have to notice it. And we should click the PC, okay, this PC0 here, and navigate to desktop, then web browser. Okay, web browser. Okay, and let's type the IP address that we've set for the 3 devices. Let's just copy it here. Okay, then let's type it here. Let's paste it here. Okay, let's search go. Okay, so let's type it here. 1.0.0.1. Okay, then after that, let's press enter. Okay, so we're gonna type username, admin is the username, and admin is the password as well. So we're gonna have to sign in. Okay. So after logging in, we shall answer this question: how many devices are displayed in the page? What are their names? So there are three devices displayed in the page. These are the solar panel, the power meter, and the battery. Because as you can still remember, we connected this solar panel, these 3 devices, these 3 IoT devices, to the same IP address. We configured it to the same IP address, as you can still remember from the previous steps. So why are the other devices, the switch, the server, and the PC, not listed? Is this a mistake? So this is not a mistake because the switch, the server, and the PC are not IoT devices compared to the solar panel, power meter, and battery, which are IoT devices, which we configured in the same IP address. So if you can still remember, we typed the IP address, and when you type the IP address, as well as the username and the password, you will be redirected to this page wherein it will show the devices you configured to the same IP address. So that's the answer for that. So it's not a mistake. It's just the correct process of configuring the devices. So we have to click each device to expand it and monitor the status of a specific device. So we have to click the solar panel. So the status of the solar panel is it has a 0 watt, okay? Then, okay, so it's actually charging. So you can see from 0 to 27 to 133. Okay, let's observe it. Yep, it's actually charging. Okay, so every time the LEDs are lighting up, the status of the solar panel becomes from 0 to 27 to 80 and then to 133 when all of the 3 LEDs are lighting up, okay? So for the power meter, we have here, its status is, yep, as you can see here, the status here is also seen here on the power meter display, okay? So as the solar panel charges, the watt per hour recognized by the power meter is increasing. So that's the role of a power meter. Then for our battery, okay, as you can see, as the solar panel charges, the watt per hour in the power meter display increases, and the battery, or the available power on the battery, increases as well. The battery percentage increases as well. So this is a good application for our IoT builds, okay, because this will allow us to connect electronic components and devices. It could be in our homes or it could be in any location. So for our last part, our reflection, okay? So the power of this IoT solution becomes clear when a user can monitor the power consumption of the system, not only locally, but also remotely. So this is good because we can monitor. We can use this as a maintenance and monitoring system wherein even though we're not on the site, on the actual site, we can still monitor the power consumption of the LEDs, or let's say our electronic devices. And we can monitor the power meter reading as well as the power being stored on our solar panel. So this is so convenient for engineers. So one step further would be to connect a microcontroller and write code to turn off and on more the LEDs when the battery power drop below a predefined threshold. So We can also connect a microcontroller such as an Arduino or let's say a PIC3, then create our own codes to control and to manipulate how the LEDs will behave and how they will function in accordance to the battery percentage, okay, or the status of the battery. So this is really convenient. Okay, knowledge about this leads to energy saving mode, which would allow the battery some time to recharge before the LEDs could be brought up again. So this is really advisable or very helpful for engineers to be able to have a system of maintenance for our electronic devices connected to switches and to our server. So that's our experiment number 2 for our Internet of Things laboratory. So again, my name is Rica, and I hope I will be seeing you on our next vlogs. Bye!